Welcome to the webinar, The Future of Work, Integrating Emerging and Cross-Cutting Technologies. I'm your host, Mike Zackary. This is a part of our continuing webinar series in preparing technicians for the future of work. Joining us today is Nicklin from the National Center for Autonomous Technologies, and I'll introduce Zach in just a moment. Let me tell you briefly about our project. We have a number of project goals in preparing technicians for the future of work. Let me just focus on the first and the last one. Empower community colleges to prepare technicians for the future of work. And number 4, foster implementation of the cross-disciplinary STEM core to maximize impact on technician education. You'll see that'll be our focus today. So what's happening out there in the world of work? Well, that nature of work is changing at unprecedented speed. And many of us know that machine learning, AI, Internet of Things, robotics, other technologies are eliminating some jobs and creating others. And technicians sit at the center of much of this disruption. We as educators have to keep up, and our students' career path, they're going to evolve, that's for sure. They're going to change. I like this term, future-proofing STEM technicians. Well, how do we do that? Well, we've developed the cross-disciplinary STEM core that focuses on what we call major buckets. There's 3 areas of them. I think a more formal term would be skill areas, right? Data, knowledge, and analysis is one, advanced digital literacy, and finally, business knowledge and processes. Those are the 3 that we have focused on, and by integrating the cross-disciplinary STEM core, we hope to future-proof our technical programs. What exactly does this mean? Well, there's a lot of small words here, but you can see there are these 3 major areas. Focus on the middle one. We'll be touching on it today, advanced digital literacy. This means that our technicians, our students, should understand digital communications and networking, cybersecurity, machine learning, sensors, programming, robotics at a higher than an introductory level. So you can see in Zach's remarks today, he'll be addressing many of these topics in this area. It's my pleasure now to invite Zach Nicklin, the UAS Director at the National Center for Autonomous Technology. Zach, introduce yourself to the audience.
Absolutely. I appreciate that, Mike. So, as Mike said, my name is Zach Nicklin. I've got a couple of different roles. The primary one we're talking about today is as the UAS Director and the co PI at the National Center for Autonomous Technologies, where we really focus on these emerging technologies in the uncrewed space, whether it be driverless technology, driverless vehicles, underwater ROVs, or autonomous underwater vehicles, and then of course our unmanned aircraft and other emerging aviation technologies. And so I'm also the UAS program manager for Northland Community and Technical College, where it's a Part 147 aviation maintenance school located in Northwest Minnesota. Today, as Mike said, we're going to talk a little bit about converging technologies. And the way I like to paraphrase this or to capture this is as a single doorway to multiple educational and career pathways. This presentation is really going to be focused on what we're calling our core autonomous systems technician pathway that we're helping to develop. So here's my contact information. If anybody has any questions, after viewing the recording, please feel free to reach out to me. When we talk about this convergence, I'm not going to read the full definition here, but if you look under subsection 2 there, it creates new pathways, opportunities, and frontiers and competencies, knowledge, technologies, and applications. And that's really the part of it that we're going to focus on here as we start talking about this project. So what I'm going to do first is I'm going to introduce you to some of to some of these industries that you may be unaware of, or you may not have the information necessary to really move forward with this. So we want to start here. So right now we're going to talk about advanced air mobility. And advanced air mobility is really the concept of a safe, automated, and affordable air transportation. Whether we're talking about cargo organizations such as Amazon, Wing, Drone Up with Walmart. There's lots of organizations out there that are delivering groceries and things like that. Just kind of that last mile delivery aspect. But we've also got organizations like Beta Technologies, Joby Aviation, Lilium, and quite a few others out there that are really looking at personal mobility. So we're looking at essentially sky taxis. If you're my age or older, you may remember the Jetsons, where everybody was flying around in their own little flying car. And this is the next step in that direction, really. And so when we look at the suburban sprawl and urban congestion, these are being built as a way that we can kind of short circuit some of that. Whether it's a taxi system between 2 points, or whether it's actually going our two stationary points, or whether it's going essentially, door to door. Some of the things that we'll notice about these about all these technologies that I'm talking about, programmable routes. We use sensors to both determine its own internal state and to navigate and move through its environment. Many of these technologies, they're either hybrid or fully electric, and they tend to use higher voltages than what we're typically working with, whether it's the automobile or the aviation industry. And we have driverless vehicles, and I've got a few examples here. Again, these are ways that we can increase mobility, that we can decrease congestion, and then, of course, take the human error out of this transportation system. Right? Humans, we are prone to error. Things happen. We get in accidents. Billions of dollars a year are spent on accidents in the driverless vehicle or in the automobile space. And once we have a system where not only is the all the vehicles talking to each other, but also talking to the roadway and its environment, hopefully we'll be able to mitigate a lot of those accidents, going forward. But again, it's sharing some of those same technologies that are being used, right? We're still using the same type of sensors. We're using electrical propulsion systems, and frankly, the electric propulsion system, it doesn't care whether it's driving a propeller or if it's turning a wheel. Next, we got autonomous underwater vehicles and ROVs, so remotely operated vehicles. These are made, they perform missions underwater in environments that aren't easily accessible to humans. They're used as backups. They're used to explore whenever we have things like, a ship sinks, or we're missing an airplane that falls into the ocean. It's these type of vehicles that go out and locate that debris. Again, packed with sensors. These are platforms for the cameras and sensors on them. Sometimes they may have manipulator arms, but the technology is very, very similar when we start pulling out these new technologies. So I'll slip
Hey,
to the
Zach, I was just reading about that underwater stuff. There's this whole new industry of underwater mining. Isn't that starting to happen now? That'll be all autonomous, won't it?
Right, when you're looking down at the bottom of the seafloor, it's very
Yes.
hard to have, manned or crewed vehicles down there. If you just look at some of the recent happenings with the manned sub that wound up sinking, it
All
was all
right.
news for the last couple months there. It's things like that we want to avoid, and we can avoid that. We can increase our safety case by using this new technology, and that's the same regardless of the industry that we're talking about.
Okay,
Uh,
thank you.
and then you can take that same mission profile, and we can apply it to space operations, right? Because there's been talk for years of, mining space and some of the asteroids or comets out there. We're currently, performing resupply. We're doing data gathering and exploration missions in both near and deep space with uncrewed vehicles. And really, the beginning of our space program began with uncrewed vehicles. So we're sending these probes out into deep space, and we're getting imagery and data that we otherwise wouldn't, with this type of technology. And then you've got organizations such as SpaceX, and they've got these booster rockets that are coming back and landing all by themselves. So really, it's this type of technology, regardless of the industry that we apply it to, is really starting to take over a lot of our lives, right? And I'm not saying that necessarily in a bad way. I'm just saying it's becoming ubiquitous everywhere we turn, right? I mean, I personally don't fly without a small drone that I bring with, and so I can go out and explore in the new places that I go to and take pictures. And there's plenty of other people that work much the same way. So as we're talking about these different industries that seem really unrelated, again, when you take a look at them, they're very heavy on the sensors, on computer maintenance, on networking, the different components being able to talk to each other. And as we got the National Center for Autonomous Technologies together, and we started bringing these SMEs or experts within these fields together, we started to really see a whole lot of similarities between the things that we were doing. We all had cores that we were working on. So the automobile industry, you have the core, you still got to be able to change brakes and tires and all that fun stuff. Then we look at the aviation side, and you still got to do the same type of thing, which, I mean, you know, planes have brakes and tires as well. But when we start talking about this new technology that we've added on to make things more efficient or safer, a lot of those technologies really, really look the same and they perform the same. So we started to investigate a little bit, and we started by bringing 5 folks into the room, and basically we locked them in there for about 5 days as a part of this project, and they each had a standard that they went by. Now, it was NACD Mechatronics, it was the SAE Automotive Part 147 or the Airman Certification Standards for Aviation, and then a UAS maintenance standard and an international ROV standard. So we brought representatives from each of those standards into a room, locked them in there, and said, "Hey, you're not coming out until you figure out what do you have in common, right? Where is this core that goes across the board?" And we started to really bring out, as I said before, hydraulics, pneumatics, computer maintenance, networking, electricity, and electricity is kind of a big one there. But what we put this together. We put a whole report on it. There'll be a QR code coming up if you're interested in the report. But we developed this Excel spreadsheet that kind of broke all of this down right into categories. Because sometimes on the UAS side, on the unmanned aircraft side, I'd be talking one thing, and the guy on the automobile side was talking another. But as we dug deep down, we found we're actually talking the same thing. We just use different nomenclature, right? And so we decided that okay, well, we've got to have headings and subject areas that really go across the board. And so that was kind of part of the work as well. And then
Zach, let me interrupt. What is ETAS again?
sorry, with this slide here, I'm getting to that there, but that's electronic technology automated systems.
Odd
So
systems.
think about
Okay, good. Thank you.
robotics, industrial robotics, that type of stuff, right? And so as we started to dig and find these, I took a couple of examples, and right now what you're looking at is examples of coursework offered at Northland College. And you can see that aviation maintenance has a 5 credit basic electricity. The ETAS program has a 6 credit basic electricity. Automobile has 3 credits, and construction electricity is 8 credits. Now, I fully believe that there are different things that folks need to know, regardless of based on what field they're in, right? The aviation side, we don't get into PLCs and controllers for some of the manufacturing type equipment, right? And construction electricity, well, they've got to know things like the National Electric Code, right? Which some of the other organizations don't deal with. But when you dig into the details of this, 3 to 4 credits or so really is the same across the board. All right. And so we start looking at efficiencies and in this case, inefficiencies. And basic electricity is really just an example. There's multiple areas where this happens. And again, the computers and the hydraulics, pneumatics, that type of stuff. So when we dug deeper into this, we found that, hey, there's a core here. And this core here can go across the board. So right now we've got 4 different people teaching 4 different classes that most of it really is the same. Right. And so we're not very efficient there. And I know some educators might not be happy with me when I say this type of thing, but the reality is that colleges are losing funding, right? We're losing state funding, we're losing federal funding, and being able to keep our doors open and keep our programs going is something that we need to look long and hard at, right? So having one person or one core electronics class and then breaking out, so in this case, we'll say a 3 credit basic electricity class that any of the students from any of these programs can take. And then the construction electricity adds the extra stuff they need. Aviation adds the extra stuff they need. ETAS adds the extra stuff they need, right? So it would take a couple of credits out of an instructor's hands, but it would make things more efficient. And more importantly, when we look at this core that goes across these multiple programs, a lot of students that I get, they're heck, even 18 to 35-year olds. I mean, I'm 40 and almost don't know what I want to do with my life, right?
Mhm.
So being able to start into a program and take this core would give you exposure to all these different pathways, right? And so you'd be able to really have a make an informed decision on what you want to do. And regardless of which way you go, you've already started knocking stuff out, right? It's not, well, let me go take my generals and then explore these other courses here to see what I want to do. It's let's take this core and that's going to expose me to these other things that I can do. So looking through the process of where we're going with the project that we're doing right now, identifying a common core was our first step there. So we got that checked off. So next we're working to develop credentials and then really establish this pathway So it's getting buy-in from industry and other academic partners, and that's kind of the step that we're working on right now. And then we're going to follow that up with creating a curriculum and really link it to individual industry. So getting folks to stand up and say, "Hey, this is an entry level into where I need to go from the industry side." And then from the academic side, it's going to be acceptance, right? If you have this core, can I join your advanced automotive program? And will I have credit for these type of things? And so it's really helping to create those pathways for students. So ideally, this core would be a standalone entry level, way to get into a company. But of course, you still need the training on those specific systems, whatever it is, right? Whether it's vehicles or aircraft, things like that.
Right.
So as I said before, there is a QR code here. This will bring you to the NCAT website, specifically to our download of the report. It is rather lengthy, but if it's something that interests you, feel free to go there. Also explore the other resources that are on the NCAT website, all free to use. We've got some great resources out there. Some of the barriers that I see to change to making this, maybe a little bit more difficult, but not impossible, is stovepiping. So we run into this, my automobile program is exactly what it needs to be, and they need to go through my electricity class because I talk specifically about automobiles, right? And you get the same thing on aviation and the other sides. The reality is the electrons don't care, right? They're going to act the same regardless of where they're flowing in what system, right? Because we're all using wires, we're all using the same type of thing. So they don't care, and it's something that we need to maybe work on getting past ourselves, right? Credit load requirements, that's going to be a significant one, right? Yeah, you got to be able to justify your job. I've got a credit limit that I've got to hit every year as far as with classes taught, and there may be some changes to that or creative workarounds that need to happen. There'll be significant front end work. I don't know about how things work at your colleges, but being able to get folks from different departments together on a reliable basis over and over again to really work through the front end of this is going to be time consuming, right? There's going to be some front end work there to make it happen, but I think it'll really streamline things in the end, and hopefully add to the student body within the programs, right? Because now we've got just this more open front end that allows for those different pathways. And then, of course, will the core credential be accepted? If we can't get industry buy-in and acceptance on the academic side, that's going to make things a little bit harder. So, with that, again, just contact information at the end there, and that's going to be the end of my slideshow there. I'd love to field any questions or anything, Mike, that you may have.
I do. Could you reshare your slide there for a moment, Zach, and go back to that one right there? This core credential, is it issued by the college? For example, they've completed 4 courses and we call that a credential or a certificate, or is it something that's validated by industry? What exactly do you mean by a core credential?
Right, and I'm looking at it multiple different ways. Again, we're still I wouldn't say we're at the beginning of this project because it's not the beginning. It's been a long road to get to
Sure,
even where
sure.
we're at, right? But so I'm looking at it multiple ways. I'm looking at, for instance, individual community colleges. We've got over nine. I think the last time I looked, it was like 916 community and technical colleges, or community and technical colleges here in the U.S. And they represent a significant block of education, right?
Right.
So if we can get those folks to start running this, and here's the way I see it: these type of programs, when we talk about unmanned aircraft, advanced air mobility, aviation, advanced automotive, they're expensive programs, right? And technology moves really fast. So when you go in and you invest a $500,000 into a program, and then a year and a half later, your stuff is really seen as out of date by industry. That's hard to justify, and
Yeah.
and not a lot of folks have the budget for that. But almost every community and technical college I've looked at has some basic computer technology courses. They have some basic electricity type courses, and they've got courses within this, hydraulics and pneumatics. And so if they can piece this together and allow a local student to come in, gain this knowledge and this certificate through them, and establish a pathway with another college that does have the funding and the ability to host one of these programs like a
Sure.
UAS program, and make sure that there's an articulation agreement in place for those pathways. So that's really what I see. Is it'd be opening up. You'd keep a local student local as much as possible, but then they'd be able to matriculate into these other programs to get specifics, or from there go into the workforce, depending on what that student wants to do.
Good. Oh, by the way, we appreciated that you locked these people in the room for 5 days. I wonder how they were when they came staggering out afterwards. I thought that was interesting. But,
Well, I did let them, go to the hotel and sleep at night and to eat
okay.
and stuff. But no, it was a great group of folks, like I said, that represent kind of all sections of the industry that we're looking at, everything from educators to industry personnel, and it was a great group of folks to work with.
What I thought was fascinating was the breadth of the industries that you address. You started today, right? We're talking about the marine industry and others. You didn't mention agriculture. I sort of asked this tongue in cheek. Does anyone drive a tractor anymore, or are they all autonomous?
Right, right, absolutely, and I'll tell you this is there is no standard out there that we found,
Okay.
or representative, right? So that's where we started was with we needed actual standards in place, not what this guy thought,
Uh-huh.
right? We wanted to go from that because if there's a standard in place, it's at least been industry accepted and accepted by academia, right? And so that's where we wanted to start from. But yeah, it goes beyond just the things that I talked about here, right?
Sure.
Looking at agriculture, I know like UND's down the road and they're buying big into the space aspect. So there's quite a few different industries or verticals that this would absolutely apply to. So
We have another question that's come up, Zach. You mentioned, and I think people see this right away. For example, the electronics and electricity is a good cross cutting across the core of those various programs. That's important, but there must be other things. Does things like you mentioned sensors, what about data acquisition, data analysis? Is that starting to be common across all of these programs?
Absolutely, because at the end of the day, the computers have to be trained, right? If it's going to be fully autonomous, it's got to understand its environment and what it's looking at.
Right.
So data analytics, not only data for the sensors of whatever vehicle it is, right? To make sure that it's understanding its environment. But a lot of these are also used to capture data as a part of its operation, right? So when we look at unmanned aircraft, it's a platform for sensors essentially that flies. Same with the underwater, AUVs and ROVs. They're essentially platforms for sensors. So yeah, so big data storage, the analytics. I mean, those are going to be huge parts of it. On my side is really I have a focus on maintenance, and so
Mhm.
that's kind of where my niche is there. But there's absolutely room for other places there as we start expanding and into other job titles, within some of these verticals.
In the approach, this is the last question, Zach. In the approach that you're taking at the center there, let's keep our focus on data analytics or data acquisition for a moment. Do you think there should be a separate course developed that is common in these various programs? Or let's suppose you were king, would you rather see it integrated across into the programs instead of as a separate standalone course? What do you think would be the right approach?
Well, that's a tough one, and I think part of that's also going to depend on what outcome you're looking for.
Uh-huh.
Are you looking for someone who is a pure data, analytics type person, or data visualization, that type of stuff, versus do we have a technician who needs to understand what data is coming through here and verify that it's the correct data?
Yeah, yeah,
I think it's kind of two different levels there. And really, if you dig down deep, you could make it a whole lot more than two levels, right?
yeah.
So that's a good way for me to skirt around your question there.
Okay,
So I think like in many things, it depends, right? It depends on what outcomes you're looking for.
sure.
I could definitely see both pathways depending on what you're trying to do.
Oh, there's a good picture of you, Zach. I like that one by the air. That's a is that a drone?
That's an RQ-4 Global Hawk.
Holy cow.
Yeah, so it's got a 130 plus foot wingspan and flies for 24 plus hours.
So we wanted to thank Zach again for his presentation today, giving us a sense of how autonomous technologies are part of a cross-disciplinary core in the approach that they're taking at the center. There are tools in addition to the ones that Zach mentioned. He talked about the KSA analysis. That's an important tool. On our website, preparingtechnicians.org, all one word, preparing technicians, You can read and share a framework for cross-disciplinary STEM core. That's about a 5-page PDF. We have something called instructional cards. I'll show a picture of them in a moment, but there are short time classroom activities that you can do to start implementing these cross-disciplinary skills. You can listen to podcasts in our series that feature cutting-edge industry interviews, and you can share recorded interviews like this one. I mentioned those instructional cards. I've shown in those same 3 buckets again, look at the middle one, advanced digital literacy. You can find instructional activities. They're short. They can go right into the classroom on the Internet of Things, automation, robotics, digital twins, network architecture, and more, just to give you an example. These are all free and they're downloadable directly from the website. I mentioned the podcast. Here's some examples. We talked about the marine economy, Zach. Justin Manley in episode 38 talked about the new blue economy. I like that word, blue tech or blue economy. And boy, was it robotics and autonomous systems. That was one of the features things.
Absolutely. And Justin Manley is a great guy. I've had the opportunity to meet him, so he
Oh,
works
good.
close.
I'm good. I'm glad to hear it. Also, there's a companion document that allows you uh, to look at these podcasts and decide, okay, what's in there for me? What can I learn from them? What use of it? You get to scan through it rapidly instead of listening to all 44 of the podcasts. So take a look at those. There's recordings of this webinar series. This is a continuing series. The first 3 were preparing technicians using the cross-disciplinary STEM core, the next one on professional development resources, and the third one on integrating emerging technologies. Zach, this is going to be the 4th in the series, and all of them are going to be available at preparingtechnicians.org/webinars. Colleagues, thank you very much for joining today. Zach, we appreciate your effort and all the work that you and your colleagues at the National Center for Autonomous Technologies are doing.
Well, thank you, Mike, and you as well. The folks over there, preparingtechnicians.org and Cord, you guys are doing some great work as well. So thank you for having me, and
Appreciate it.
I really appreciate that.
Colleagues, that officially concludes our webinar for today.